permutations and combinations can cause problems for some people. This person knows the secret. And so if you can tell me who that is, that's a picture from an old basketball trip, one of my favorite people. If you can tell me who that is, I'll buy you a gift. First person that can text me, I'll buy a gift from BC when we get back. All right. Combinations and permutations are figuring out different ways to order or group things and different numbers of ways of grouping things. And so we're dealing with numbers here. And instead of worrying about what the combinations necessarily are, this whole unit is simply about that. How many? And everything we're going to do is based on that premise. Here's a cafeteria that's got a lunch special. A drink, a sandwich, and a dessert. We want to find out how many different ways we can order. What are some different combinations? If I take a look at the sandwiches, I've got 2 options. I've got 3 drink options, and I've got 2 dessert options. I could list them all. I could list all of them. That's what the first question is, list all the possible meals. I'm not gonna, because it's gonna take forever, but I could have egg, a milk sandwich, a milk and a yogurt. I could have an egg sandwich, a what am I doing? A juice and a yogurt. I could have an egg sandwich, a milk, and a coffee, and bleh, whatever. It would take forever. There's only 12 of them, but it would take 2. I'm considering a shortcut. And so I want to take a look at a simpler way of doing it. If I just look at the sandwiches and the drinks, ignore the desserts. I could have an egg sandwich with milk, I could have an egg sandwich with coffee, and I could have an egg sandwich with juice. There's 3 ways there. I could have a tuna sandwich with milk, a tuna sandwich with juice, and a tuna sandwich with coffee. Another 3 ways to do it. Well, there's 6 different ways there. Well, if I take a look at just how many sandwiches there are and how many coffee or drinks there are, there's 2 different sandwiches available. I'm going to list those. And there's 3 different drinks available. I'm going to list those. Well, if I multiply those combinations out, I get 6. Well, that's a simple thing to do. And that's what we're going to work on, is what is simplest. So 2 times 3, I'm going to take the number of sandwiches there are. I'm going to multiply it by the number of drinks there are. 2 times 3 is 6. If I want to know how many with all 3 in there, sandwiches, drinks, and desserts, I would simply multiply the 3 different groups together. Oh, that's a 2. Why did I put a 3? Love the delay when you're working with a smart board. Like so. And again, that's how many different sandwiches, drinks, and dessert meals I could get. All right. So we're going to be doing some counting, and we're going to simplify it as much as we can. Okay? Now, the fundamental counting principle. This is the first page of your handout. And so you might want to take a look at this while we're going through it. And the fundamental counting principle simply is a simple way of organizing and multiplying. If you take a look at this word, here's an example. Word micro. And the question isn't put them in list the different ways. It's just simply how many ways can I rearrange the letters in micro? Well, if I take a look at the first letter, I've got none of the letters written down yet. I'm going to start writing out letters. How many different letters would I have an option to choose from? I could choose the M, the I, the R, the C, the O, in any order. So that gives me 5 different options I could choose from. So let's say I pick the C. Well, how many letters are left for me to pick from for the next number of the combination, or for the next letter? And that would be 4. Let's say I pick the O, which would leave me with 3, which would leave me with 2, which would then leave me with 1 as I work my way down, as I fill these spots in. Well, 5 times 3 times 2 times 1 is 120, which we have right here. So that's easy enough. But then I've got an issue where, what happens if I've got the word Mississippi, where there's 11 different letters? 11 times 10 times 9 times 8. Well, that's going to be problematic. The calculator solves this problem for you. There's a button on your calculator that looks like that. It's called factorial. And the factorial button takes the number you start with and it says, you know what? I'm going to multiply that all the way down to 1. I'm not going to multiply 0 because if I multiply 0, every answer is going to be the same. So I'm not going to do that. But I'm going to multiply it down to 1. So if I take a look at example 2, how many different ways can 8 albums be arranged? Well, it doesn't matter if I take the oldest album, if I label them my favorite albums, the prettiest albums, whatever. I have 8. So that means if I listed them out in a, let's get rid of this. If I listed them out and labeled them, 1, 2, 3, 4, 5, 6, 7, 8 different spots, that would mean I'd have 8 albums to choose from to put first. Which now, since one of the albums is gone, I would have 7 for the next spot, which would leave me with 6 and 5 and 4 and 3 and 2 and 1. Well, I don't want to take my calculator and go 8 times 7 times 6. My fingers are fat, and I'm going to miss, and I'm going to have to try about 4 times to get it right. I'm going to hit 8 factorial, which is what they've done down here, and you'd get 40,320. What you have to do is you just have to, depending on your calculator, find this button. It might be X exclamation. Most of them are N exclamation, but one might be X. And then pop that in your calculator and get it. If you're not sure, if you've got a graphing calculator and you can't find it, it's because it's in the mode button. So it's in the different section. It's the probability section of your graphing calculator. So use these instructions here, which you'll see a little bit more clear when I come up here. That's where you'll find it. So you have to go to mode and then over to probability and then slide across till you see that option right there. So if you've got the graphing calculator, that's what you would use. Here's a question. The next page, same page in your handout. How many ways can the letters in the word pencil be arranged? It don't matter what order they go in, but there's 6 of them. So if I've got 6 different choices, I could have any 6 of those letters be my first option. Let's say I pick the E to be the first option. That means there are 5 letters that are left available to me to choose from. So let's say I pick the P, which leaves me with 4 letters to choose from, and 3 and 2 and 1, which is 6 factorial, which is 720. Okay? If there are 4 different cookies, how many different ways can you eat them all? And again, it's not which one, not what, just how many ways. Well, there's 4 cookies to choose from. I eat one. That means there's 3 cookies left to choose from. I eat one. 2 and 1, which is 4 factorial, which would be 24 ways to do it. Okay? So here's 3 other questions you can work on. There's the answers for you right there. I don't think you're going to have much of a problem with this. Here's one thing we do have to take a look at, and it's a different set of parameters or restrictions. Sometimes, didn't want that. Sometimes they'll say the numbers can repeat. And sometimes they'll say they can't. Well, you have to kind of know what that means. So in this case, and this is out of your work text. Your work text on page 689. So that's what we're working here. 689 in your work text. If I've got repeats available to me, well, let's say I've got a situation here where I've got digits 7, 8, 9. I've got one of those little locker things where I spin and I can go 7, 8, 9, or cryptex like they would on Da Vinci Code or that Apple, which is a huge combination of different letters you could have. In this case, I've got a small one where the digits are 7, 8, 9. Well, if I'm allowed to repeat them, meaning that I could have a 7, 7, 7, 8, 8, 7, where the digits can repeat, I have to look at each specific spot in that cryptex, and I'd say, well, in the first number, first slot, I could have any one of those 3 numbers. And because repeats are allowed, I could have 3 in the next one, which means in the last spot, I could have any 3 of those digits, 7, 8, or 9. Well, when I multiply up those combinations, or those different numbers, I'd have 3 times 3 times 3, which would give me a total of 27. If repetitions are not allowed, changes things completely. So that if I take a look at my cryptex and I'm in the first slot, I can pick any one of those digits. I could pick a 3. I have 7, 8, or 9. I've got 3 different options to choose from. But since repeats aren't allowed, that gives me only 2 options to choose from now, the 8 or the 9. So I would pick one of the 2, which would leave me then only one option remaining for the last digit. And so when I multiply these numbers up, I would get 6. And there is, and I don't have to tell you this, there's a huge difference between, it wouldn't take me very long. If I was trying to bust this one, it would take me a little bit longer to do. All right, so this, and I don't know why that didn't work, but you'd find this on page 689 of your work text, okay? Which is a good spot to turn to, because we're going to go now to page 688. We are going to go back one, I thought. I guess we're not just yet. Oh, there it is. Okay, well, we'll go back there. Wow, now what is happening? I don't know what's going on, kids. Help. One. All right. Good times. Okay, here's the situation. Jeepers creepers. Wow. Almost wanted to swear right there, but I didn't. Good for me. Okay. The original Baskin Robbins has 31 flavors. You've also got an option of 3 different cones. You can have a sugar cone, regular cone, or a waffle cone. Okay? So there's my cone options. So suppose you have a double cone with 2 scoops. Well, the first question would be, how many, I don't know what's going on. Why is this not working? How many different choices of cones do you have? Well, I've got 3 choices of cones that I could work with. So I've got 3 cones that I could play with, choose. How many choices of flavors do I have for the first scoop? Well, I've got 31. And how many choices do I have for the second scoop? I've got 31 of those as well. Well, the question is then, how many different double cones are possible? Well, 31 times 31 times 3 gives me an answer of 2,883. So it would take you, if you had 1 cone, double scoop cone a day, it would take you forever. Wow, I just don't get this right now. But we're going to suffer through, kids. 2,883 different choices here. All right, changing page. All right, this is page 688 of your work text. And again, here's a different situation where they've got repeats available. So Alberta assigned license plate with 7 characters, replacing the old 6 character plates. So how many different license plates were possible with the old plate? Well, you'd figure out there was 26 and then 10 different numbers. 3 letters, 3 numbers, 26 available, 10 digits available, which would give you a total of 17,576,000. If I added another character to that, which they did, and in this case they added another digit, I'm going to take that number and multiply by 10. So now there's 175 million, almost 176 million different combinations of license plates available to Alberta, which is, like I said, by adding 1 character, you've increased the different possible combinations by 160 million almost. So what I want you to work on for the first set of questions here is page 689 and numbers 3 to 14 and 16. 14 and 16, you got to think a little bit. And that's the whole thing with permutations and combinations. You've got to be able to wrap your brain around what is going on. So that's the end of this particular section. And then when you're done this, you can take a look at the next video, which will get you through the actual introduction to permutations. All right, good luck.